All right, we're going to go over some questions from section 8.2 from the Practice of Statistics 5th edition. Specifically, we are going to take a look at number 31, 33, 41, and 43. Find Z star for a 98% confidence interval using table A or your calculator and show your method. It's kind of hard for me to show work on this, and because I'm on my iPad, I can't really share my screen super well. So here's what I would have you guys do. So personally, I would have you go to the Staplet. You would need to change the operation to the second option, which is find a value corresponding to an area. And because we're specifically looking for Z star, the distribution of Z scores has a mean of 0 and a standard deviation of 1. So you would need to plug that into your calculator or into the Staplet. And a 98% confidence interval means that the area in the middle is 98%. So on the Staplet, you could either do a central area of 98%, or I would be tempted to do the thing where it says left tail area. And this is actually how you would look it up in a table as well, because tables always give the left tail area. If the middle is 98%, then that means this is 1% and this is 1% underneath there, because that would add up to 100. So left tail area would be 0.01. And when you look that up, the Staplet tells you that the Z score here is negative 2.326. But of course, with a Z score, with a critical value, with Z star, we're going to just write the positive version of that down. If you looked that up in table A, the closest thing you could get to an area of 0.01 would be an area of 0.0099, and that's a Z score of 2.33. So it's still really, really close. This question is really the main deal. Like this is kind of the whole point of this chapter, what we're dealing with here. So I feel like most of you guys had no problem with most of this, but I thought that it would be good to walk through just so you have an example of the whole process from top to bottom. Tanya wants to estimate what proportion of her school seniors plan to attend prom. She interviews a simple random sample of 50 of the 750 seniors in her school and finds that 36 plan to go to prom. Identify the population in the parameter of interest. So to me, it looks like the population is the high school seniors at her school. So high school seniors at Tanya's school. The parameter, though, is not the number of high school seniors, but the proportion of her school seniors that plan to attend the prom. So we would say P equals the true proportion of seniors planning to attend prom. It is important to put all that stuff, even though it's kind of long. Notice that I did give the symbol is P. All right, the second thing is to check the conditions. You might remember there are 3 conditions. This is very important. Condition number 1 is that it is random. So I'm just gonna write down the 3 conditions. So random, and I'll put a little ... and explain. It says in the problem that the sample was a simple random sample. So I'm just going to write sample is simple random sample because it says it right there. That's the first condition. The second condition is the 10% condition. So it says that she surveys 50 of the 750. So 50 is less than or equal to 1/10 of 750. So we're good. Okay. The last condition is the law of large counts, because we need to see if this is approximately normal so that we can use a z-star. Law of large counts requires us to do n times p. Now, we don't know what the true p is, so at some point we probably should establish what p hat is. So p hat is the sample proportion, and it's 36 out of 50. So the law of large counts has us do n times p, which clearly is 36. That's greater than 10. And then n times p minus 1, which is, 1 minus p, which is this, and that's 14, and that is greater than 10. So law of large counts, random, 10%, that is all met. We've checked all the conditions. Hooray. Part C, construct a 90% confidence interval for P. All right, now the general formula for a confidence interval is you find the point estimate and then you do plus or minus the margin of error. On the AP test, they're going to ask that you write down the formula, like actually write the whole formula down as you do this. So that is going to be P hat plus or minus z star times the square root of p hat 1 minus p hat all over n. Like that's how we find p hat is the point estimate, and then the margin of error is found by doing z star times this. If it's a 90% confidence interval, we're going to need to look that up on the Staplet, or maybe you already have it written down for what the z star value is. The z star is 1.645. So that's going to be my z star. So this is going to look like, let's see, 36 out of 50 is my p hat. That's 0.76. No, sorry, 0.72. So I'll have 0.72 plus or minus 1.645 times the square root of 0.72 times 0.28 all over 50. And we do need to show your work. That is important. When I subtract, when I do 0.72 minus that, I get 0.62. And then when I do 0.72 plus that, I get 0.82. Okay, so there's my interval right there. That's part C. Then part D says interpret the interval in context. Also very, very important, but remember all this is a script. You just need to remember the script. We are 90% confident that the interval from .62 to 0.82 captures, and you have to think about what we're trying to do. If you go back to the beginning, we wrote down what we were trying to capture. We were trying to capture the true proportion. Remember that was our parameter. So, oops, sorry, I meant to write true. Captures the true proportion of high school seniors at Tanya's school who plan to go to prom. Next step, have efforts to promote equality for women gone far enough in the United States? A poll on this issue by the Capable Network, MSNBC, contacted 1,019 adults. A newspaper article about the poll said results have a margin of sampling error of plus or minus 3 percentage points. The news article said that 65% of men, but only 43% of women, think that efforts to promote equality have gone far enough. Explain why we don't have enough information to give confidence intervals for the men and women separately. Okay, so just keep in mind, to find a confidence interval, this is what we need. And you notice in this formula, there's an n, a lowercase n. And if I wanted to find the sample, like if I wanted to do this for them separately, I would need to have a sample size for men and a sample size for women. But all I have is a sample size for adults. So that's the issue with A, is I don't have a sample size for both of them separately. So I don't have a sample size for men or women. Part B says, would a 95% confidence interval for women alone have a margin of error less than 0.03, about equal to 0.03, or greater than 0.03, and why? You can see the news article statement. Okay, so if the margin of error is this part of the formula. And the newspaper article up here said that it was plus or minus 3 percentage points, but that was when the sample size was 1019. So the thing is, for women alone, their sample size is going to be smaller. So if I'm dividing by a smaller number, that means that the total number underneath the square root is going to be larger. And then that means that the margin of error is going to be larger overall. So for women, it's going to be larger than 3% because it was 3% when you had everybody put together, and the women are going to have a smaller sample size. Okay, last question for this one. PTC is a substance that has a strong bitter taste for some people and is tasteless for others. The ability to test PTC is inherited. About 75% of Italians can taste PTC, for example. You want to estimate the proportion of Americans who have at least one Italian grandparent, and who can taste PTC. How large of a sample must you test to estimate the proportion of PTC tasters within 0.04 with a 90% confidence? And answer this question using the 75% estimate as a guessed value for p hat. Okay, so here's what I know from this problem. P hat is 75%. I want my confidence level to be 90%. And I want my margin of error to be within 4%. So that means I want it to be less than or equal to 4%, 0.04. So that's what I've got. Essentially what we're doing here is working backwards. So the formula for margin of error is this. And I don't know what n is. So let's kind of plug in what I have. If my confidence level is 90%, my Z star, I could either look this up on the table, you could look it up in your notes, you could look it up in on the calculator or Statlet, but we actually found it earlier and it was 1.645. So my Z star is 1.645. My P hat is 75%. I don't know what n is. And I want my margin of error to be less than or equal to 4%. So that's kind of what I'm working with here. I just need to do some algebra with this. First thing I will do is divide by 1.645 on both sides. Then I am going to get, and I divided by a positive number, so my inequality sign is going to stay the same. I'm going to go ahead and multiply 0.75 and 0.25 for the numerator here. Okay, so the next thing I need to do is square both sides. And I get 0.0005905. So we're getting very small here at first. I need to multiply both sides by n. And then when I do that, I'm going to actually have to divide that little tiny decimal to both sides to get the n alone. I end up getting 317.5, so we'll need to round that up to 318. So my sample size needs to be 318 or more if I want my margin of error to be 4% or less. So I basically just started with the margin of error formula and solved for n. Now that was what it is for part A. Part B asks us to answer the question again, but this time use the conservative guess of 0.5. And by how much do the samples differ? So I'm not going to work the whole entire thing out. My z star is the same, but this time instead of using 0.75, I'm going to use 0.5 and solve. The reason for that is because that is the most conservative guess. It's right in the middle. If I go less, if I go like 0.3, then I have a 0.7 to go with it, and so like 0.5 is basically like the most conservative guess you can have. So if you don't know what your p-hat is, they always just use 0.5. That's kind of standard practice. When I solve for n, in this case, I end up getting 423. So for this one, this is 105 people larger than the first example.